Hello my dear lovely students, welcome back to my math distance learning session. Today we are going to be starting a new topic which is the set theory. So I am beginning the first session of set theory today, which has a small topic, introduction to sets. So this is another topic which is going to be very useful for grade 9 and 10. So let's get started. So in the session today you are going to learn what are these sets and what are the basics. So we are going to look at some terminology related to set theory in this session today. And before we start, let's get to know the learning objective for this session. In this session, you are going to define what are sets, look at some examples and some of the basic set notations. You are going to be learning new terms which are going to help you throughout this unit of set theory. So let's get started. So let's understand the first key concept for today, which begins with the definition of a set. So what is a set? Let's understand. So a set is said to be a collection of well-defined objects, and the objects which are there in the set are called as the elements or the members. So there are some important things for sets that you should be knowing. The elements which are there in the set, or the objects which are there in the sets, or the members which are there in the sets can either be numbers, it can be letters, or it can be some objects also. Usually your sets are written with the capital letters like capital A, capital B, capital C. Each object in the set is called an element or a member. That is what we have already seen in the definition. And when we read the definition, we saw that it is a collection of well-defined objects. So this is very important. Whatever objects are inside the set, which are the members or the elements, have to be well-defined. Okay, and this set is going to be a collection. So we may see some examples in the slides to come where you would see how and what different types of sets can be there. Okay, and another important thing that you should remember about set is that the elements are listed inside curly brackets. So for example, I'm taking a set capital A, then I'm going to be putting that equal to the elements which are inside. So they have the curly brackets and inside it has the elements. So it can be A, B, C, D and so on. Okay, this is a general form of a set and the definition. Let's get to know more about sets and take examples in the slides to come. Okay, now sets, they can be two types basically. It can be an infinite set which has uncountable number of elements, or it can be a finite set which will have a finite number of elements that we can count. Also, sometimes a set may also be an empty set. So in that case, it will have no element inside. We are going to go in detail in the next module on different types of sets that are possible. But till now, till this slide, you should know at least these two cases where it becomes finite or infinite. So let me give you an example of a finite set. I hope you all can see this set A, which has some number of elements, and I can write this set A as equal to the curly brackets, and then inside I'm putting all the elements which are separated by commas. So let's count. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So I can say that this set has 9 elements. Definitely it is a finite set because we can count the total number of elements present. And what is this set denoting? It is denoting the set of single digit positive numbers. So this is the way you describe your set. Okay, let's take another example. This is set B. Now set B has 3 elements. And you can see they are the 3 different colors that I've selected here. One is red, one is blue and one is yellow. So I can write my second example of set B, which has 3 elements, and the way I can describe this set is that it is the set of primary colors. Last example that we will take here is set C. So here in this set you are given the number line, and you can see the number line I've taken 0, 1, 2, 3, 4, 5, all these digits, and my set C is defined as the set of all those x which are lying between 0 and 5. So here this is the set of all numbers between 0 and 5, and therefore we cannot really count the number of elements. There are so many numbers in between. So this set is going to be another example of a set, and this time it is not finite, it is infinite, as there can be so many numbers in between. So even decimals, rationals, irrational, and so on. So these are some examples of set, and I hope you can all see that all these three sets are well defined. That is, the elements which are inside are characterized very clearly. You know what are going to be the elements, you know how the set is described and what all it is containing. So this is all about examples on set. Let's now move further and get to see some very special types of sets. Many of you have been using these sets till now in your mathematical journey. So these sets are all infinite sets, as you would see. So the first set that I'm taking here is the set of natural numbers. You all know that 1 is the smallest natural number, so this set of n will have a minimum. Yeah, so it begins with 1, then the next natural number is 2, 3, and so on. And I hope you are able to see these 3 dots. So these 3 dots denote that this is a process which is going to continue. That means this set is going to have more and more elements. So can we say that this is going to be an infinite set? I'm sure you will agree. Okay, and then you have the next set, which is the set of whole numbers. This also is an infinite set. It begins with 0, the smallest whole number, so it has a minimum again, but it doesn't have any maximum, so it is going to be a uncountable set. Then you have the set of integers, which is denoted by a capital Z. Again, it is an infinite set. It includes both positive and negative integers and 0 as well. Then you have the next set, which is the set of rationals, and it is described as the set of all those x such that x has the form of a rational number, which is p over q, and p and q here can be any element of the set of integers. So it can be positive, it can be negative, but there's an important condition: your denominator cannot be 0. So in order for this rational number to be well defined, your q should not be 0. Then we have irrational number set, which is denoted by a capital H. Similarly, your real number set and your complex number set. I hope and I believe that you have understood that all these special set of numbers, you can clearly see that these are going to be all infinite sets. They have so many elements which we cannot count. Next, we are going to learn what are subsets. So for explaining you the concept of subsets, let me take an example here. So I have a die which I'm rolling. So the question is, what is the set of possible outcomes on rolling of a die? So I hope you all can see that there are going to be 6 outcomes: 1, 2, 3, 4, 5, 6. So there are going to be 6 possible total outcomes when you roll a die. Now out of this whole 6 outcomes, if I just have to select the set of possible even outcomes, then what can be your possibilities? I'm sure you would agree that there are going to be 3 possibilities or 3 elements in the set of possible even outcomes, and that is going to be 2, 4, and 6 out of this 6 options. Therefore, in that case, we could say that AE, the set of possible even outcomes, is a subset of the total set of possible outcomes from rolling of a die. So AE is a subset. We have already seen that because it contains some of the elements of A. Now, if we talk about the 2 important sets, the universal set and the null set, then these 2 sets are going to be always the subset of every set, because the null set doesn't have any element and the universal set has all the possible outcomes. So it is the largest possible set for a given scenario. So these two are going to be always the subset of a given set. Now one important thing, for your subsets, the notation which you are going to be using is this one. So we say that AE is going to be a subset of A if we can write them in this way. If all the elements which are there in AE are a part of A. Yeah, so that's what is about subset. The all possible outcomes of AE should be the elements of A. Now, before we dive in more into the lesson, I have a question here for you. What is set notation? Think about it, and then you may just pause the video and check your answers. That set notation is a system of symbols which you are using to define the elements of a set. Also, you will see in the lessons to come that we are going to illustrate the relationship among sets using the set notation, and also we are going to perform some operations among the sets using these set notation. In short, we could just summarize that set notation is very, very important, because those set of symbols you are going to be using for any operation that you do among the sets or to define their relationships. So pay attention to this session that we are going to be doing today. It's an elementary introduction to your set theory and your set notation. So let us take a few more examples of your set notation. The first one we have already discussed. This is the set notation that you're going to be using when you are denoting a subset. So A is said to be a subset of B, or A is said to be contained in B if you are going to write it in this manner. So when you say like this, it says that A is contained in B, or all elements of A are part of B. Now let's take another reading notation here. This is going to be very, very important. You are going to be using a Greek letter epsilon. So this one is epsilon. And why is this used? It is used when you are trying to denote that whether an element is a part of a given set or not. So let me take an example to explain this epsilon to all of you. So I have this set B, and as you can see, this set has 5 elements: 1, 2, 3, 4 and 5. Now if I ask you, is 1 belonging to B? That means I'm asking you, is 1 an element of this set B or not? And yes, you can all see that is there inside the set B, so that comes out as a true statement. Next I ask you, is 6 belonging to B? And all of you can see here, because there are only 5 elements, so this is a false statement that 6 belongs to B, or we could say that 6 does not belong. So you write the epsilon and you strike it off. That would tell you that 6 is not an element of B. So we use this epsilon notation, we use this reading notation to check or to say whether an element is a part of a given set or not. So we can conclude this by saying, if X is an element of a set A, then we write it in this manner, and if X is not an element of set A, then we write it in this manner. And how do we read? We say epsilon means it is an element of, or it belongs to this set, or epsilon, which is stricken off, is not an element, or it does not belong to the given set. So this reading notation is very important. You will see in the slide today some questions where we are going to use the epsilon notation to solve problems. Okay, so this is a short table which I have put here for you, which you should remember and use when you are trying to solve a question on set notation. So let's quickly review them. So the first one is epsilon. We have already seen it says, or it means that it is a member of, it is an element of, or it belongs to. If you have an epsilon which you have striked off, it says it is not an element or not a member, and it does not belong to the given set. Next you have your curly brackets, which are denoting a set. So inside a set you have elements, and you write the set with the elements within the curly brackets. Then you have this bar which denotes such that, or for which you use usually in your set notation while you are writing the set or while you are describing the set. Again, another way of writing such that or which is the semicolon. So these are some symbols with their meanings which are frequently used to denote sets. So you should remember them, and while you are solving question, this will be really useful for you. Now I'm going to take an example which will further elucidate your epsilon usage. So here the set which is given to you is a finite set A with curly brackets and 4 elements. So here if I take these elements, element 1, then we can say it is an element of this set because it belongs to, and we could write 1 belongs to the set A. Similarly, for element 3, it is there in the set and we can write 3 belongs to A. But if I take a different number which is not in this set, for example 8, then I could say that 8 is not an element of A, and that's why we write it in this manner. 8 does not belong to A, or you write an epsilon and you strike it off. Okay, so now let's see, students, what kind of question can come in your exam. So we are going to solve 2 parts here, 3A and 3B. I've taken this from your textbook and let me read it out for you. Decide whether each statement is true or false. So this is a question based on your epsilon. I hope you remember the epsilon notation. So if you have epsilon only, it means belongs to. And if you have epsilon which is having a mark on top, it is striked off, it means does not belong to. So let's check. We'll do 3B first. So for the 3B, the set which is given to you is 2, 5, 8, 11 and so on. So as you can see, because you have the dot dot dot, it is going to continue, so it's an infinite set. But before we check whether this element 21, this is the element which is given, and we need to see whether it is going to belong to this set or not. We have to see what is the pattern in this set. So let's note that. So how do I get 5 from 2? I add 3. Again, I add 3, I add 3. So the pattern that you observe here is that each element has 3 added to it. So to get the next element, just keep on adding 3. In that way, if we follow the pattern, we can write the elements, more elements of the set. So let's write them. So 2, 5, 8 and 11 are already given. Let's keep adding 3 to check whether 21 is going to be a part of this set or not. And then if it is coming, we will say this is true, otherwise it will be false. So let's do that. So I'm adding 3 here, it becomes 14. I add 3 again, 17. I add 3, 20. I add 3, 23. So we just need to do it till here. No need to do more, because 21, if it is a part of this set, it will lie between this, it will be lesser than 23 for sure. So that is all. And you can see here the pattern which is followed of adding 3 to each element. If we are following that, we are not getting 21 in between. So 21 is belonging to the set, that's what is given, and definitely it is not true, so it is going to be false. So 3A, 3B is done. Let's look at 3C now. So I'm going to write it here. So for 3C, you need to say that MAP. So this is one element. First, I want you to note that, girls. MAP. So it's not 3 elements, it's just one element, MAP. And this, the question is saying, does not belong to the set of 3 different elements, M, A and P separate. So you have these 3 elements. It is not belonging, and definitely that is true. I'm sure you all can understand that this is a true statement. It is going to be true here, because on the right you have the set which has 3 elements, 3 distinct elements, whereas this MAP is together just one element. So both are different and not same. So that completes your example. Okay, let us solve one more last question together, which is again I've taken from your textbook from the guided practice. I'll read the question for you now. Write the set of months that end with the letter Y in the English language. So first of all, I want you to know that it is quite a well-defined set. So you are taking what? You are taking the set of months. Okay, and you know your months have a specific name and we are considered only for English language. So let us write all of them and then we'll select the ones that we need. So January, I will write the whole thing because we have to look at the complete spelling. We have to just see which are the ones which are ending at Y. So yes, so January, then February, March, April, May, June, July, August, then September, October, November, and the last month, December. So we have written all the 12 months, 1, 2, 3, 4. Let's number them to make sure we did not miss any. Okay, so wonderful, we have written all 12. Now out of these 12, we don't need all 12. We just need the ones which are ending at letter Y. So let's pick up the ones that we need. So I'm going to highlight those for you here with yellow. Maybe let's see how it is coming through. Oh, so okay, so I'm going to just circle them with red. So yes, January, it is ending at Y. February also ending at Y. May, then July, and that is all. Yeah, so you have 1, 2, 3 and 4 months which are fulfilling the condition that's given in the set. So we need to write the set of months. Let me just denote it with a capital M that end with the letter Y in the English language. So now I hope you all can easily see that this set of months is a well-defined set. Let me now write this set. So the set M, we put the curly brackets and then we write our 4 elements: January, February, May and July. So this set of months that end with the letter Y has 4 well-defined elements. So that completes our solution. That is all for this session today. It was a short lesson on introduction to the sets. In the session today, you have seen what is set theory, some basic notations, and in the sessions to come, we are going to work more on sets and get to know more details. So before we end the session, I would urge you to revise the session, and we are going to meet in the next session and get to know more about sets. That's all from my side. Bye students, and don't forget to like, share and subscribe to my channel for more math videos. Bye-bye.